So today we're going to use base 10 blocks to model a multiplication question involving decimals. And what we're going to build using the base 10 blocks is an area model, which will help give us the answer. Before we can do the area model, we need to make sure that we're clear on what each piece represents. So this flat square here is representing one whole. And the reason it's representing one whole is because this side is worth 1, this side is worth 1, and when you think about the area of a rectangle or square, our area is going to be length times width. So 1 times 1 is 1. So the area of one flat square is one whole. This rod represents 1/10. And the reason it represents 1/10 is because this side here, just like this one, is worth 1, but this width here is 0.1 or 1/10. So when we think about the area of this rectangle, we're going to do 1 times 0.1, and we get 0.1 or 1/10. 10 of these will fit inside one hole, okay? So this is a 10th. And this cube is worth 1/100th or 0.01. And the reason for that is because just like this side is 0.1, so is this one. So this is 0.1, this side is 0.1, and 0.1 times 0.1 or 1/10 times 1/10 is 1/100th. And 100 of these pieces fit inside here to make a whole. And also 10 of these pieces would fit inside here to make a 10th. So that's what all the pieces are. And if you're a teacher looking at this video and maybe thinking that you would like to use it to help your students learn these types of questions with multiplying decimals, I would recommend always having an anchor chart up in your classroom somewhere with exactly the dimensions and what each block represents so that they remember. So the question that we're going to look at today is 1.6 times 2.2. And how we're going to do that is we're going to look at making an area model with a rectangle so that one side is 1.6 and the other side is 2.2. Okay? So I'm going to start with one whole, and I'm going to use this side here to make my first length here, 1.6. So there's 1, and now I need 0.6. I'm not going to use these because that doesn't really make sense. I'll need a lot of them. I'll need 10 of them, in fact, to fill up this length. So I'm just going to use my 10th blocks or 10th rods because one side here is worth 0.1 or 1/10. So I need 6 of them. So 1, 2, 3, 4, 5, 6. So there's 1.6 along this side. Okay. Now along the top, I'm going to show the other length here. So that's 2.2. So I have 1. I need another one, and I can fit it right here. So 1, 2, and then I need 2/10. So I'm going to use these. 1, 2. So now I have my area model. It's not complete at the moment though, because I'm supposed to make a rectangle with this, and I have a missing piece in here. So in order to figure out what my answer is for 1.6 times 2.2, I want to complete my rectangle and then figure out what my rectangle is made up of, because the area inside of it will give me the answer to this question. So I know that this piece in here is not going to fit. It's too big. So I'm going to use my rods to fill in this part, and I'm going to need 6 of them to match up with the other 6 there. So 1, 2, 3, 4, 5, 6. And this is good for students to do too, because it's kind of a trial and error. And, you know, if they try to fit some pieces in and it doesn't work, then they can go to the smaller pieces and keep kind of building it on that way. And then again, I know that this side here, I'm not going to be able to use a rod because it's definitely too big. So I'm going to use some of the smaller cubes, which are worth 1/100th each. So 1, 2, 3, 4, there's 6, almost done. Okay. So I now have a complete rectangle. So this is my full and complete area model for the question 1 6/10 times 2 2/10. So what's my answer? Well, to figure out my answer, I'm just going to count up what I have in here, and I might have to do some changing of rods into holes and some of the cubes into 10th pieces so that I get the right answer here. So I'm going to count. I got 1, 2 holes, but I remember that 10 of these makes up another one. So I'm going to see if I have at least 10, and I'm going to trade it out for another flat square. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these 10 can come out and can be replaced with another flat piece there. Now I don't have another 10 of those rods, but I do have at least 10 of these cubes, and I know that 10 of them make a rod. So I'm going to see if I can find 10 and then again switch them out. So 2, 4, 6, 8, 10. That brings me in another rod here. So now I'm going to count exactly what I have left over here. So I have 3 holes, so 1, 2, 3. So my answer starts with a 3. I have 1, 2, 3, 4, 5 tenths, and I have 2 hundredths. So my final answer is 3.52. And although these manipulatives are really good for students to use, and you know they can swap things out and they can really see what's happening, they're very hands-on. Some students with sensory aversions may not enjoy this at all, or they may get frustrated pretty easily. And if that's the case, then there are lots of websites that have virtual manipulatives of base 10 blocks that they can use. So in the comments, I will put a couple of links there that might be useful for your child or for any of your students who would prefer to use virtual manipulatives instead of concrete.